Okay, how's that? All right. So again, what I am going to do today, I'm going to show my ability to produce mind over matter. You can see there is a paper clip there. I am going to think sink, and the paper clip will sink to the bottom of this bottle. So it does require concentration, and it helps if I really look at this. Maybe it helps if you do a motion as well. So well, that worked. If you stop concentrating, though, it goes back to the surface. All right. This is one of the little fun things that I like to do here at the Nature Center. We can do some magic, but it's really just science. And we're going to learn how to make one of these today. So the first thing we need to do is get a 2-liter soda bottle. All right. The clear ones work better because you can see inside of it. I know some of them have the green bottles or different colors. Those will not work as well. The other things you're going to need: a straw, some paper clips, and I have different paper clips because you might need different sizes. Hot glue gun, I use that a lot. I've got a glass of water. I've got some extra water. We'll need that later. And then there are some other things we can do with it as well. And we're going to use a test tube, and we're also going to make a little diver, which means we will need this. You can use one of those pie pans, pie plates, anything like that. So yeah, that's about all of the things that we're going to need. And what we're doing is we're actually making a Cartesian diver. And that's what this is here. Also, when I first learned this, we learned it as a diving bell. All that is, there's a little piece of straw in there that the paper clip is attached to. Okay. That's pretty fun. All right, let's angle this down a little bit so you can see what I'm doing. Hello, Marlborough, Cromwell, Westerly. I want to thank everybody for tuning in. Please continue to put up where you're messaging us from. I always love to see where people are messaging from. I want to thank everybody that tuned in on Saturday to our program with Dr. Nick Bellantoni on the Native Americans that lived along the shore. It was fascinating. I learned a little bit there, and I've heard him do that talk before, and I still learned something. So you're either I'm not remembering it, or he's making his program a little better each time. But you can watch that program if you scroll down on our timeline on Facebook. You'll get to see it. It's also going to be up, I think it already is, up on YouTube and on our website as well, meigspointnaturecenter.org. or the Meigs Point Nature Center YouTube channel. And please subscribe to our YouTube channel. Also continue to follow us and like us on Facebook. All of the followers are helping us to do these programs. Okay, I'm going to lower the camera a little bit so that we get a better angle of our diving bell. There we go. Okay. So again, this is what we're going to be making. So the first thing we're going to do before we make one of those diving bells is we're going to make a diver. And here are my scissors. I don't know if I said we needed scissors, but we do need scissors. You want to cut out a rectangle, maybe a very long rectangle, out of the aluminum there. Aluminum foil doesn't work. It's not stiff enough or heavy enough. So you want a nice piece like this, and you want it to be able to fit into your bottle. Okay. The next thing you're going to want to do is just shape it a little bit more like a diver. So I'm going to make a oval for the head. That was always something I found fascinating in art class, when you start to diagnose the shapes of people and their features. Most people draw a human head as a circle, but our heads are not circles, not even close. So making a oval for the head. So we're trimming up some arms here. It's quite simple. You just cut in like so, and then we'll cut off the ends so we've got more of an arm shape there. And then we're going to cut a little slit there for our legs. Doesn't have to be too perfect, just the idea that we have a diver. We're going to, you can leave those legs a bit long too, because they are going to be, you know, divers have those big fins that they wear. Okay, so here is our diver. The next thing you're going to need is your straw. A bendy straw works best. So you want to bend the straw, and then you're going to cut it about 1 inch down. My first cut, I always cut it a little long because you can always trim it, but you can't make it longer. So there's something I learned doing carpentry. And now you're going to need a paper clip. Let's try this one here. So you're going to need to slide each side of the straw onto a different point of the paper clip. That paper clip is stuck together at the end. Okay. There we go. So you're going to want to put the ends of the paper clip in there. Now, many of you may have done this experiment in school. This one I did not do in school. I didn't do this one until I got here to the Nature Center. Now, coming in from the side, let's go from this side. You're going to slide the paper clip up onto the diver. I put his arms in the way there. Okay, so now he's got, or she has, their little air tanks. Now you need your glass of water. This is where we test. And it looks a bit too buoyant there. That's sticking out of the water too much. So we need to trim down our straw. Put the paper clip back on. Put it back onto our diver. Still a bit buoyant, but we can try it. I did make one earlier, so there's a little diver there, which sinks a little bit more. You want to see more of this closer to neutral buoyancy. You want it on the surface, but not sticking way out of the surface. This one, I think I really need to, there's a lot less weight on this one. So we need to shrink those tanks again. Now we go back to our 2-liter bottle here. And I do have some tweezers to remove it. And we're going to put our diver in. So again, this is Cartesian diver or Cartesian diving bell. And the way this works is there is air inside of the straw, his tanks. When you squeeze the bottle, you are compressing that air, and the weight of the diver becomes greater and it sinks, greater than the density of the water. Okay? And then it swims back up to the surface and back down again. You can try and hold him in a neutral position there. All you have to do is find the right amount of pressure. Right about there. This is challenging. One of the things, you can turn this into a game where you pick a line and you see who can keep the diver on the line or get the diver to the line fastest, or who can hold him on the line the longest. And a little more pressure. It really takes. There we go. Neutral buoyancy. That's what scuba divers need. When you're diving, you want to achieve neutral buoyancy so that you're not forcing yourself to swim down or up. You want to get neutral buoyancy. Holidays won't be lonely with this diver. Yeah, these are a lot of fun, especially if you have kids. And these are all things that you can do in the kitchen. I'll do a couple more kitchen experiments before Christmas. And we'll probably do some kitchen crafts as well. I know I want to make some Christmas ornaments coming up. So we'll see what we can do. So there we go. Down like that. Now, the way this works, there's a buoyant force, which is the weight of the fluid that is displaced by the body. And that's how this actually works. And what I explained to you before, the sinking condition, that is when the average density of the body, so that's the mass of the body divided by the volume of the body, is greater than the density of the fluid, which is, in this case, water. So if you could look into this little compartment here, when I squeeze the bottle, the pressure increases and the water comes up and the volume of air decreases. Okay, and that's what causes it to sink. And then when you relax, that pressure is released and it can rise. And it can go up and down. There is another way we can demonstrate this. We're going to use this is going to be tough to fill up here. I should have had a big pan or something here, but we're going to put water into our test tube. And I sort of have created a central line there. So I need a little bit more water. That might be too much there. So when we turn it upside down, that's sort of the middle of the thing. And that's what I want to get, is just about the middle. That's pretty close. The top of that line there, that's where I'm trying to get to. So now the hard part is we have to get it into the water. I need to put more water in. This is going to spill a little bit. This works better if you have a large beaker, because you can stick your finger into the water, and that's what I need to do. I need to get that in before the water escapes. There we go. So now we should be able to see the amount of air in the bottle, in the vial, change. So let's see if we can go like this. Let's lower the camera again. So we'll get it right down. And the legs just went. Hold on 1 second. We can do this. All right. Are we ready? Science in action. Let's go like so. We'll turn it so you can see. So you can see the line of water is just above that green sticker in there. And I'm going to turn the big light that's overhead off. We're going to make this science experiment work. I see Judith asked a question, does the Nature Center need craft materials? And we're starting a campaign with the Friends of Hammonasset. The help of the Friends of Hammonasset, we're going to be asking people to drop off supplies that we need. Craft supplies are on that list, so look for messaging coming out. It'll probably be on the website, on the Facebook, and on the Friends of Hammonasset website and Facebook as well. We're going to ask people to drop your, if you have anything. I know people are cleaning out attics and things right now, so if you have craft materials, office supplies, we're actually looking for a couple of sets of shelves we're rearranging and things like that. You can drop them off on the back porch of the old Nature Center. So yes, we are going to be asking for your help. Okay, so again, water is just above the sticker. We squeeze. You can already see the water is rising. It's above the sticker. It is about 1/4 of an inch above the sticker. Let's see if we can hold it right about there. Come back up. There we go. And all right, I think I'm having too much fun with this. If you squeeze it fast, it'll drop quick and then you can release it. The fastest, you can't get it to go up much faster than that, but you can watch the volume of the air changes. So the clear vial, the glass vial really makes a good example. You can do this with pipettes. If you cut the end of the pipette off, sometimes you do have to put a little weight on it, like hot glue a nut on there or something. You can also use the old glass eyedroppers. I think the eyedropper, you just put that in upside down and it will work. You might have to put a little water in it to get it to balance. But these are fun things that you can do. I'm going to show you one more. Now that we have the straw, now that we have pieces of straw, so this is the one that I made earlier, but you can just take a piece of straw. Got to estimate again where it's going to be. Use a little hot glue. I use hot glue a lot. Let's get this over here. So a trick that I learned, when you put the hot glue in, it likes to flow down really quickly. So if you cool it quickly, it won't flow down into your straw and create a gap. All right, did I just make a gap? You blow on it, no air coming out. Now we're going to take a piece of a paper, or just slide a paper clip on the end there. Very simple. Drop that in. Way too much buoyance. You can see, look how high up that came. So you're going to cut a little bit off of the bottom of your straw. This is a really good experiment to do in your kitchen. Right next to the sink, it makes you get a lot of water all over the place. Oh, still way too buoyant. Gonna have to take some more water out of there. More water. More of the straw off. My goodness. I feel like that's already too much. Why is that happening? Let's try this here. Yeah, that is very buoyant. We're going to have a very tiny piece of straw here at this rate. Perhaps I used too small of a paper clip. All right, do we have any questions? I'm not seeing any questions. Remember, we're going to continue to do these programs Tuesday through Friday at 11 o'clock. You can see our past programs on our YouTube channel, Meigs Point Nature Center YouTube channel. You can also see them at meigspointnaturecenter.org if you visit the Virtual Learning Center. So there we go. We've made a little guy there. And wow. I can't squeeze enough. That straw is still too long. There is an occasion where you can get it so that because the density of water increases as you get lower, all the water on top is pushing down. There is a point that you can get it that it's buoyant when it's at the surface, but as it gets closer to the bottom, it's going to sink and it will stay sunk. And that's if you're really too close to neutral buoyancy from the beginning, that's what's going to happen. And I just keep cutting that straw down to a little tiny nub now. Let's see if that works. You could also put a little bit of water into the straw. And there we go. There we have our diving bell. So again, this is known as a Cartesian diver. You can look it up on the internet and see some additional information about it. It's a great little science experiment to explain pressure, especially pressure at depth in the water. And again, the deeper you go, the more pressure there is. All the volume of that water is applying pressure downward. And I have a lot of fun doing this. Imagine a 3 or a 4-year-old getting to squeeze the bottle and make it go up and down and up and down. It is great fun. All right. Maybe too much information. There we go. So do we have any questions? Trial and error, all part of learning. Yes. Science invented things by mistake. I love that comment. Thank you, Amy. That is exactly true. This is not something that you're going to get it, boom, right off the bat. First time. You might get lucky, but trial and error. And then the fun part is you can begin to experiment. You can try different things for weight. You can try different things to hold water. The diver looks very different than the diving bell or the test tube. And then you get the pipette or the eyedropper. You can experiment with it. You can use this in your classroom, or if you're homeschooling, you can use this and have the kids write up what it is, what causes the effect. They can do the equation, the mass divided by volume greater than the density of the liquid. So once you figure those things out, sometimes you can decorate your diving bell. If you put something on it, you can put wrap it in string or yarn and see if that changes the buoyancy, changes the density. Lots of things you can do. And again, this will entertain for hours. Entertains me. I've been working on this for an hour. All right, let's try the one that we're going to have to trim it down a little bit more. This is the one we were making before. Maybe a bobber for a fishing bobber. That might work. Just remember, that in order for the pressure in the straw to change, both one end of the straw has to remain open. So, if I put hot glue on both ends of the straw, in this case, then the pressure inside is not going to be able to change. However, if you apply enough pressure that you can squeeze the sides of the straw, it will. And you can do that. A pipette works really well for that, because when you squeeze the bottle, the sides of the pipette will squeeze in as well, and you can show that as an example how that actually works. We're going to get our diver put back together here. Now again, I want to remind everyone that the Connecticut state parks are open. Please get out and enjoy them. Today is going to be a cold day here at the park, but still a good day to visit. I think I bent my paper clip so much here. There we go. Doesn't want to fit together. And again, we test it in a glass of water. I think that's too much buoyancy, but we can try it. One of the things that you can do also, instead of continuing to trim down the dive tanks, we can add a little weight to the diver's feet. So I bent over some of the aluminum there. We're going to take some aluminum that I trimmed off from the diver's head, add it down to the feet, fold the feet over again, so we can add weight to our equation. So instead of decreasing the volume of air, we're increasing the mass of the diver. It looks like I may need a little more, but we're going to try this one. One of the fun things that we have done here at the Nature Center in the summer and when the building is open is we will take a bowling ball down to the water and throw it in and watch it float. So that's a good explanation of displacement. It's gonna go, there we go, there, slowly. This is a very slow and a lot of pressure to make it dive, and it won't go all the way to the bottom. This one's easy to keep in one place because it's just squeeze as hard as you can. So we still need more weight and less air volume there, so. All right, do we have any questions? You can make these little diving bells. We will put this up on our website, meigspointnaturecenter.org. We'll list some of the things that you need. It's really simple: paper clips, straw, a little hot glue, and a 2-liter bottle of water. And you can do this at home. You can do this if you want to entertain the other people in your house. Take this out. You can impress them with your ability to make your diving bell go up and down. See how long it takes them. Once you put it together like this, see how long it takes them to figure out that you're squeezing the bottle at different pressures to make it go up and down. All right, I want to thank everyone for watching today. Please continue to follow us and like us on Facebook. Watch our YouTube channel. Please subscribe to the YouTube channel. As soon as we get 1,000 subscribers, we'll start to do these programs, Facebook Live and YouTube Live. So that'll be lots of fun. Until tomorrow, this is Ranger Russ signing off from the Meigs Point Nature Center. Thank you for watching.